show a P2WPKH output to a Bitcoin node from 2014, and it shrugs. Anyone can spend this. The script is just a 0-byte and a 20-byte hash. No signature check, no opcodes. Yet it's one of the most secure outputs on Bitcoin. Why? The witness left the room. Rewind to the script old nodes to understand. A legacy pay-to-public key hash output runs 5 opcodes: OP-DOP, OP-hash160, the 20-byte hash, OP-equal-verify, OP-checksig. To spend it, the owner provides a signature and public key inside the input scriptSig, the unlocking script. The node concatenates scriptSig with the output script and executes the whole thing. The signature gets checked against the transaction data, and the consensus rules verify the result. Crucially, the signature lives inside the transaction body. That means signature data contributes to the transaction ID. Any malleation of that signature changes the ID. A problem SegWit was designed to fix. SegWit collapses that 5 opcode script into 2 pieces of data. The new P2WPKH output is just a 0-byte followed by the same 20-byte public key hash. That's it. No DOP, no hash160, no checksig in the output script. The leading 0 is the witness version 0 of the SegWit program format. The 20 bytes are the witness program, the data that identifies what's logged. Future witness versions can introduce new rules without disturbing version 0. This compact pattern, version-byte-plus-data push, is the entire shape of native SegWit. 5 opcodes shrunk to 2 pushes. But where did the verification logic go? It moved out of the output and out of the input entirely. Here's the segregation. The signature and public key lift out of the input scriptSig and drop into a brand new structure attached to the transaction. The witness, the input itself becomes empty. Scriptsig is blank for native SegWit spans. The witness sits alongside the transaction, carrying the unlocking data, but it's not part of the transaction ID computation. That single change kills signature malleability. Third parties can't tweak signatures to alter transaction IDs anymore. It also enables a fee discount because witness bytes count less toward the new weight limit. SegWit-aware nodes know to look at the witness, fetch the signature and pub key, and verify them against the 20-byte hash in the output. Same cryptographic check as P2PKH, just performed against data stored in a different place. Now the puzzle from the hook. To a 2014 node, the output script is just 2 data pushes. Execute 2 pushes and the stack ends with a non-empty truth value. By the old rules, that script evaluates as valid. Anyone can spend. So why isn't it stolen? Because miners and economic nodes upgraded. SegWit is a soft fork, a tightening of consensus that older nodes still accept. Upgraded nodes recognize the version 0 pattern and enforce real signature checks via the witness. Old nodes see a permissive script and trust the upgraded majority not to include thefts in blocks. Backward compatibility through deliberate ambiguity. Looks loose, enforce strict. Simple payments are one thing. What about multisig? Take a company requiring 2 of 3 signatures on its treasury. Legacy pay-to-script hash wraps the multisig script with OP-hash160, a 20-byte RIPE-MD160 of SHA-256 digest, and OP equal. The spender reveals the original script and signatures in scriptSig. The SegWit version, P2WSH, replaces this with the same compact pattern, 0-byte, then a 32-byte SHA-256 of the script. Notice the upgrade. P2SH uses RIPE-MD160 over SH-256, producing a 20-byte hash with roughly 80 bits of collision resistance. P2WSH uses raw SH-256, 32 bytes, with 128 bits of collision resistance. For complex scripts where attackers might grind colliding alternatives, that jump from 80 to 128 bits matters. Stronger hash, same pattern, witness data stored separately. Both native types share the same pattern, version byte plus a push. So how do nodes tell them apart? By length alone. After the 0 version byte, 20 bytes means treat the program as a public key hash, P2WPKH, verify a single signature. 32 bytes means treat it as a script hash, P2WSH, the witness must include the actual script plus its inputs, and the script's HS2-6 must match. Length disambiguates the twins, no opcode, no flag, just byte count. One critical rule about who builds these outputs: only the receiver should construct a P2WPKH address and only from a compressed public key. Why? A spender cannot safely auto-convert someone's legacy P2PKH address into a P2WPKH address to save fees. Two failure modes. First, the receiver's wallet may not understand SegWit, funds locked, possibly forever. Second, P2PKH addresses can be derived from uncompressed public keys, and SegWit consensus rules forbid uncompressed keys in version 0 programs. A future soft fork could render such outputs unspendable. The hash matches, but the spend would fail. Bottom line, never derive a SegWit address from someone else's legacy address. The receiver publishes their SegWit address explicitly or it doesn't exist. All this only matters if people can actually use it. How does a non-upgraded Alice pay a SegWit-aware Bob? Through P2SH nesting. Bob's wallet computes his witness program, 0 byte plus 20 byte hash 160 of his compressed public key. Then it hashes that entire program again with hash 160, SHA-256 followed by RIPEMD 160, and wraps the result as a standard P2SH address starting with 3. Alice's old wallet sees a normal 3 address and pays it like any other P2SH output. No upgrade required on her side. When Bob spends, his scriptSig contains just the witness program itself that satisfies the outer P2SH check. The witness structure carries his signature and pub key. SegWit-aware nodes recognize the nested pattern, verify the inner SegWit rules, and Bob still gets the fee discount. The same trick works for multi-sig, a P2WSH program nested inside P2SH, one address format, 2 layers, full backward compatibility. Step back. SegWit shows the shape of every Bitcoin upgrade. New rules arrive as a soft fork, a tightening that reinterprets scripts or nodes already considered valid. Witness version 0 claimed 2 patterns, 20 byte programs for single keys, 32 byte programs for scripts. Future versions remain free for new constructions. P2SH nesting provided the escape hatch, letting the network adopt incrementally instead of all at once. One warning carries forward. A 3 address tells you nothing about whether the recipient is SegWit capable. It might wrap a SegWit program, it might be classic multisig. Only the receiver knows. Years later, Taproot landed as Witness version 1, a 32-byte program with entirely new spending rules, using the exact same upgrade machinery. The witness left the room. The door it walked through is the one every future upgrade has used.